Friends, we're 3 years out from the launch of ChatGPT. Now is the time to look back a little, reflect, and understand what has worked, what hasn't, and how we're gonna make things work. For that, I think there are two events that are extremely significant. The first is that the adoption of generative ideas by consumers has been impressive. Our children, our parents, our grandparents use AI. So that's one side, the good side. On the other hand, there's another side, which is that companies haven't adopted it at the same speed, not even close. So the purpose of today's talk is to try to understand why this has happened, why it's still happening, that companies haven't managed to do it yet, and above all, what we can do so that companies can actually achieve this process. But for that, before we look at what the path is, the first thing is to understand how the process of technology adoption works. And the person who inspired me to understand a bit more about why this was happening, why consumers adopted so quickly and companies not so much, was a man named Ben Thompson, who wrote an article that, in particular, in some way described other significant waves where there were major technological changes and where there was also, notably, a certain delay in adoption by companies. So let's take a look at some of those waves. For the first wave, to tell you about the first wave, I want to go pretty far back. I want to go to Ohio in 1908 and tell you how people worked in a bank at that time, before we, the IT people, showed up. So take a look. This is a bank. This is one of the first photos ever taken in a bank in Ohio. If you look at it, there are quite a few interesting things in that photo. First, people worked standing up. It's actually pretty recent that we started sitting down to work. Next, I don't know if you can see it in the photo, but there's a cage in the back. That cage, what it had was, that's where the tellers were. That's where people worked. That's where the employees were, where customers would come and hand over money. And what you're seeing in the back is actually the back office, which is the area where the people who were responsible for recording the transactions that had taken place at the counter worked. As you can see, the way they recorded things was simply with ink, most likely with a fountain pen, in huge, heavy ledgers where absolutely everything was carefully written down. Another interesting thing is that there were only men. Well, around that time, two companies appeared, NSR and IBM, and they started talking to the presidents of these banks, telling them, I have a machine that records things much better than these people in the back office. So if you, let's say, buy our machine, you can make things much more efficient. You can automate the back office. So in this first wave, if you will, what happened was, let's say, what we focused on was automating the back office. The promise was that I would be able to do things with the machine using fewer people. But I want to jump ahead 20 years and show you how one of the first banks to accept this proposal was the Bank of America. And that was the big secret to its success for the next 50 years. Take a look at this photo of the Bank of America back office 20 years later. Now, again, there are some interesting things here. People worked sitting down, they worked with machines, and women started to appear. But the most interesting thing is that there are more people than before. That's where a paradox appeared. How's it possible that I have a machine to automate the back office, to do things with fewer people, and I end up with more people? Well, the interesting thing is that I ended up with more people because the Bank of America realized that with this machine, not only could they do the same things more efficiently, but they could also do things they couldn't do before. In other words, more than just improving efficiency, what they really did was change their effectiveness. And banks started working in ways they couldn't before, especially when it came to scale. They were able to serve many more clients than they used to. We'll see that a little later on. If I go to the 1970s, this is what the back office of Bank of America looked like in the 70s. As you can see, it was all machines. Everyone's sitting down, all women and a lot more people. That was with punch cards that were being fed into huge IBM mainframes where they recorded everything. So if you like, this first wave was a wave of automating the back office, and we can say it was a top-down wave. What happens is someone convinces the company president that something needs to be done to make the company more efficient, and that project gets done. But over time, someone realizes that by making things more efficient, they can do new things that weren't possible before and also become effective at something new. So this is the wave, our very first significant wave, to which we dedicated most of our time and effort during the early days of computing. Right around the same time that photo was taken, the second wave of computing, which brought about new advancements and changes, appeared on the scene. It appeared with this machine. Take a look. This machine, as you can see, is a machine. It's the Apple II. It's Apple's first successful product. The Apple I product was a failure, but the Apple II was a tremendous success. The machine was actually very rudimentary. Obviously, by modern standards, it's very basic, but even for the standards of that time, which was 1977, it was still pretty rudimentary. The only thing you could buy was the machine itself. Everything else, the cassette player, the TV behind it, etc., you had to buy separately. But along with this particular machine, the most interesting and notable feature, besides the fact that it was very cheap, costing only about $600 or so, was that one of Apple's co-founders, Steve Jobs, while he was working on developing this machine, was actually reading a book, specifically a biology paper. One of the always interesting things is that the great innovators tend to be generalists. That is, they don't just read about computer science, but they read about all sorts of other things and get inspiration from there. The biology paper Steve Jobs was reading analyzed how efficient animals were at moving and ranked them to see which animal was the most efficient. It concluded that the most efficient animal for movement is the condor. The condor is an animal that, by barely moving its wings, manages to travel kilometers and kilometers. Humans were more or less in the middle of the ranking, not among the best or the worst, but what caught Steve Jobs' attention was a paragraph at the end by one of the authors, which said that if you gave a human a bicycle, then they became much more efficient than the condor. You might say, well, that's pretty amusing, but what does that have to do with the Apple II? Well, the Apple II was launched with a vision. Steve Jobs' vision was, I want my machine to be a bicycle for the mind. What he truly wanted was a tremendously powerful and innovative tool for individual productivity, one that would allow people to go far beyond any other way of working that had ever existed before. What it allowed was, with very little money, it was actually the very first computer you could use without ever needing a professional programmer. Now, the reality of that computer, of that vision, was that in reality it was empty, because in practice, what was it going to be used for? However, some time passed, and again I come back to this point. There's always a gap. It takes time to realize what you can use it for. And so the vision that seemed empty ends up being fulfilled. It ends up being right and true when 2 years later, a man named Dan Bricklin was at a conference at Harvard, apparently a bit bored, and he came up with an idea that led him to create this product, this software package. It was the first killer app. What you're seeing there is the first version of a spreadsheet. It looks very rudimentary, but at its core, it's still the same spreadsheets we know today. They have rows, they have columns, you can do calculations, and so on. That first spreadsheet was called VisiCalc. Dan Bricklin created a company called VisiCorp, but unfortunately, it didn't survive the 1980s. This is another thing that sometimes happens. Sometimes those who arrive first don't make it to the end. That is, after that came Lotus 1-2-3, then Microsoft with Office, and so on. So the idea of the electronic spreadsheet continued, but what didn't continue was VisiCorp. But what's interesting, as I was saying, is that having this was the first time I had a computer that was like a bicycle for the mind. I could use the Apple II without needing to talk to a programmer to make a program for me. I would load the Excel spreadsheet and start working with it. That led to a massive adoption among consumers. People started using it, it was cheap, and they started using it. So, well, those are the two, if you will. Here we have two philosophies. The first one, automating the back office, is top-down. It's the company president who makes the decision to launch a big project, and from there it gets implemented down the line. And this second wave is a bottom-up wave, from the ground up. That is to say, there's no official company decision. Instead, people buy the computer and start using it. So these are the two philosophies. We have one that's top-down and another that's bottom-up. The thing is, now we're in the third wave. That wave, the wave of generative AI. So the big question is, which of the two philosophies will be applied in this wave? The top-down one, automating the back office, or the bottom-up one, of bicycles for the mind? The answer, and this is what makes the situation so complex, is that actually it's both. We're going to use AI for both philosophies, to do both things. In fact, one of the things we learned at Globant over these 3 years is that there are basically 3 use cases where I'm going to use AI in companies. Let's look at each one of them. The first is what we could call bicycles for the mind. It's about having, just like Bill Gates wanted a computer on every desk, now what we're going to have is an AI on every desk. Now, what are we going to use it for? So the first thing we're going to use it for is chat. We're going to use chat, just like, let's say we use it at home with ChatGPT. The difference is that if we're in a company, we have to be much more careful. Who can access it? What kind of computing power does it need? What documentation can it access? And so on and so forth. But one of the main points is to try to democratize the use of AI in the same way that the use of personal computers, PCs, was democratized back in the day. So an important component is that there shouldn't be licensing per person or per seat, but rather licensing based on usage. That way, the more people in the company who can use it, the better. Now, what is this AI used for on each computer? Well, first for chatting, asking it questions, and so on. But actually, the important point for companies is what I like to call the super search. It's the first time that we'll be able to, at a company level, query the massive amount of text that companies have at scale. For us, as IT professionals up until now, the text and documents that the company had weren't really something we paid attention to. At most, what we could do was help with digitization so we wouldn't have to store them on paper. But we couldn't really do anything. Let's say we didn't do anything particularly interesting with that. For many years, people have tried to have search like Google has for the internet. How can I have something like that for my intranet, for internal documents? That failed, actually. Google tried everything. At one point, I remember there was even a hardware you could install in your company to do that, but the truth is it never really took off. This is the first time we have a real success story. Being able to query all the text we have at scale in a secure, private way, and so on. The name for this is a bit odd. It's called RAG. But what it means is that I can query my documents, I can query my text. One of the things I do when I go to a new company that asks me how they can adopt AI, the first thing I ask is, what documents do you have? What documents? Because that's the first use case. It's like a bicycle for the mind. It's about giving each person the ability to access, of course, only those who have permission, to access the documents so they can start working in ways that weren't possible before. As time goes by, first, it starts with chat, then with RAG, and then it moves on to what we call an assistant, which is the idea that in my job, I pretty much always ask the same questions. So if I tend to ask the same questions, what I'm going to try to do is have an assistant that helps me with that. I'll give you a concrete example from my own experience, for instance. One of the things I do is check about once a month, more or less, how our competitors are doing in the low-code world. So I have an assistant to whom I said, these are my competitors. These are their websites, and I want you to check if there are any changes in their business model, any new products, or anything that might interest me. So I run that assistant or ask that assistant questions, and that's how I manage things. In practice, I have 7 assistants that help me with different topics I'm interested in. So that's the first use case. Now, the second use case is actually one that I think is super important, and in fact, it doesn't get much press, which is the case where we're going to put AI not just on every desktop, but also. We have to put AI into each and every one of our systems, making sure that all of our systems are enhanced and improved by artificial intelligence. What I mean is that the way we interact with our systems is gonna change, or at least we're gonna have a new way to interact in addition to the previous ones. Today, we can say that the way we interact, broadly speaking, is point and click. That is, I move around with my finger, with the mouse, I see something that interests me, I click on it, and then I move to the next place, and so on. Well, that way of interacting with systems isn't going to disappear. What's happening is that a new one is emerging. What's the new way? The new way is that instead of using point and click, I can tell the system my intention, what I want, and the system helps guide me to the right place. Let me give you another concrete example. The other day, we were talking with a company that has an ERP system. I asked them how many screens their ERP has, and they told me it has 3,240 screens. The question that came to mind was, how do users know which of the 3,240 screens they need to go to? Because in a way, no one logs into an ERP like they do Instagram just to see what's going on. You log in because you have an intention. You want to find something out. Like, I want to know what debt this client owes me, or things like that. The answer right now is that there are expert users who know how to navigate, how to get where they need to go, and there are others who are less experienced who move through the menu and eventually get there. But what's happening is that users have to have a mental model of how the ERP works in order to move around. Well, that's something I can completely change. What I can do now is add, let's say, an AI layer, as I call it, and when the ERP starts up, have a search box. Just like the search box you have with Google, but only for my ERP. So I say, I want to know how much this client owes me. And what the system will do is not just give me an answer, but actually take me to the right screen. Some of those 3,240 screens that have the answer. So that's called intent-based navigation. It's the first concrete use we're going to have of AI in these systems. But as time goes on, what's going to happen is something more sophisticated, where we'll move into a full conversation. Not only do I want to tell it what my intention is, but for example, I could say, look, I just sold this product. Make the invoice for me. And instead of having to go into a form and enter the data, I could have a dialogue, have a chat, and through that, the data would be entered for me. So let's say another effect is that we're going to rewrite, let's say, many of the systems, or sometimes for intent-based navigation, you don't even have to rewrite anything. The only thing you need to do is add an AI layer to each of the systems. The third use case, which is quite a bit more sophisticated and is often discussed in the media, is when I want to add AI to each and every one of my business processes, specifically to the various processes that I have within the company. We're going to call that agents in this context. And one way I see this more clearly is basically when I go to a company, I ask them where the documents are, which is what I mentioned for the first part. And for this case, what I ask is, take me to the back office, show me the people who are working, let me see what they're doing. And usually in a company that has already gone through its digital transformation, the people in the back office are doing some kind of coordination task without consensus. What do I mean by that? They're probably coordinating with clients or suppliers in a way that's pretty informal, calling them on the phone, sending emails, doing those kinds of things to coordinate some of those tasks. Well, today we have going back to the first wave, we can automate those processes in ways we couldn't before. Without AI, it just wasn't possible. Now we can do it. All right, friends, these are the 3 scenarios for using AI. We've already gone through them, and during this process, we ended up developing a platform called Globant Enterprise AI. I'd like to invite Gaston to come up and tell us what this is all about. Thank you very much.